Let's welcome Jason and let's watch this talk. And again, reminder, this is a pre-recorded session again. If you have questions, drop them in the chat and we'll see if we can get them answered.
All right, everybody. Welcome to the last day of NahamCon, and thank you for having me here to present the Bug Hunters Methodology v4. Today, we're going to take a couple hours, give or take, and talk about different methods that work for me in bug bounty hunting that I think are cool. We're going to talk a lot about tools and kind of why we use them and what we're doing with them. And I'm excited to be here today to talk to you all. So I wanted to start off the presentation with kind of the future of the Bug Hunters methodology, right? So the Bug Hunters methodology is a talk I've been doing for, oh boy, I want to say like 6 years now or something like that. There's been multiple iterations, obviously, with the versioning system. The first one was at DEF CON, and then it moved on to RootCon, and then back to DEF CON, and then all over different small conferences and virtual conferences, etc. And what happened was it just got too big for one slot, right? What I've ended up doing for this iteration is the Bug Hunters methodology is splitting into two distinct pieces. And really, a lot of the work in this presentation is based out of a live training I give that goes over 2 days. So really, you could fill a whole 2 days with demoing all the stuff in these slides. And the two sections that we're going to break that up into are Recon and application analysis, because this is usually the delineation that people have interest in when they talk to me about the Bug Hunters methodology. A lot of them really like the Recon stuff. They really like to know what you're doing in that area. And then others have feedback that basically says, I want to learn more about, when I actually land on an app, what am I doing? So today we're going to start off with the Bug Hunters methodology v4 Recon. And we're going to go through everything that I use in my hunting and talk about it. So just a little bit of an about me. My name is Jason. You may know me on Twitter as jhaddix. I'm a father, husband, hacker, gamer, and sometimes streamer, although I haven't done it in a little while. The COVID situation's been kind of crazy. I'm currently 28th on the Bug Crowd leaderboard all time. And those are my lovely children over there, my son Arlen and my two girls, Avalon and Arcadia. And that's them coming to DEF CON last year for the first time, which was really special to me. Um, like I said, I'm a gamer. I'm playing Destiny right now, Call of Duty Warzone, The Division, and Path of Exile. If you see me online or you ping me, we could shoot some stuff. That'd be cool. So the first thing in the Bug Hunters methodology that I like to talk about is it's just project tracking, right? When you're doing bounties, if you're not tracking your progress or your tool output, it can get kind of hairy. And so, some of the tools I recommend, I use very personally, I use mind maps, and I use a tool called Xmind, which a lot of people comment on. I'm kind of known for using mind maps in my tracking, but really, you just need a method that makes sense to you to track your work. So some people can do it in Excel files, some people can take notes in Vim or Notepad++. Really anything I've heard of people doing in OneNote or other note-taking programs. There's some pen test, standalone applications that are meant to track projects and pen testing, et cetera, et cetera. But project tracking is a super important part of the bug bounty and pen testing methodology. So when I do a bounty or anything like that, this is kind of how I start off, right? So here is my tool to take notes in. It's Xmind. It's making this mind map where I have a center node and I can make subnodes off of the center node. And here you can see, I start off with some light subnodes, and as I do this project over time, I'll fill this out pretty far. You can see I have my ASNs for this project on the left-hand side, and the acquisitions that this company has made in a subnode there, and the link discovery will go in a subnode there, and then a reverse whois link to get all of those things, which we'll talk about soon. And then on the right-hand side, I have started to fill out my routes, right? So, for this project, which is Tesla, you can see Tesla.com and Tesla Motors. I obviously know that I've read the scope for this project and know that Solar City and My Solar City are not verbatim in scope for this specific project. And then I have some others here too. So this is how I start to build up my mind map. This is the very beginning of it. When you move on to like intermediary and you dig down into some more of these places, it starts to look like this. So on the left-hand side, I've expanded Tesla.com, and Tesla.com has all of these sites basically that I've confirmed are up or I've discovered. And when I want to track one, you can see that Tesla.com, www.tesla.com is highlighted in orange. And when I expand out that, each expansion for me has my actual notes for that site. So doing some narrow recon. These are just places where I can stuff things, some questions I want to ask myself, like, are there multiple user roles for this site? Is there a login? How does it handle special characters? What is the technology behind it? Interesting endpoints for this exact site. And this will actually, this format will happen for all the sites that I decide to spend some time on if I deem them interesting. And we'll talk about that in a little while. So this is my way to take notes. By no means do you have to, do anything like this, but it is an interesting way for me to remind myself to do a methodology for each part of each site. So today we're talking about Recon, the Recon part of the Bug Hunters methodology. And so this idea of wide recon is the art of discovering as many assets related to a target as possible. So we want to make sure first of all, that our scope permits you testing these sites. So always check your scope. But when I think about wide recon, I think about a whole bunch of distinct pieces of work I need to do inside of wide recon. And when I start to think about them and outline them and make them in a presentation to this, the wheels will start turning in your head as well as they turn in my head. And you'll start to think about automation, how you can string these together and building a framework, et cetera, et cetera, et cetera. So these are the distinct sections of work. Find the in-scope domains, find the acquisitions, enumerate the ASNs, look at reverse whois, do a whole bunch of subdomain enumeration, and then do some port analysis. And then there's some other things that kind of bleed into they could be considered application analysis. They could be considered recon. They kind of sit in the middle, and we'll talk about some of those as well. So the first thing we have to do is find seeds, or a lot of people call seeds in recon or roots, root domains. So here we're looking at a brief page for Tesla on BugCrowd, and it's pretty easy. This is one of BugCrowd's biggest scope programs, or at least loosely scoped. You can see that star.tesla.com, star.tesla.cn, star.teslamotors.com, and star.teslaservices are all pretty open scope. That means that you can test any subdomain applied to those, and that's a pretty wide scope. And then they have this extra space down here that says any host verified to be owned by Tesla Motors is also in scope. So that's really awesome. This is a wide scope program. And so those are our seed domains, the first four that we'd probably work with: Tesla.com, Tesla.cn, TeslaMotors.com, and Tesla.services. And then we try to build from there. So this is on BugCrowd. On HackerOne, you have everybody's favorite program, Verizon Media. And Verizon Media, I couldn't screenshot the page to fit it all in one place, but basically they have a bunch of in-scope domains, and they also have a clause in their program that says if you found a vulnerability that you believe affects Verizon Media, submit it to this program. So it's a pretty wide scope program. It's like I did try to screenshot this, and it was like 8 million pages to try to bring it in a screenshot. So there's a lot of scope open here. There's a lot of seed domains that you can start with, and you would parse those immediately into your notes as places to start for analysis. So the first thing I want to do when I'm doing wide recon is understand the company a little bit, and I'm going to use two examples throughout the presentation mostly. Twitch, which we're on right now, which is awesome. So I thought I'd do Twitch, and I normally do it in my demos when I do some of this stuff live. And then I also use Tesla because I like Tesla. So here's us searching Twitch in Crunchbase, which is this business information portal that you can register for at crunchbase.com. And you can look at an organization, and it'll give you information about the organization, when it was founded. But one of the important things it's going to give us that we want to look at is the acquisitions of this company. So here I can type in Twitch. I can click on Twitch, and it'll give me some information about the acquisitions on the next page. One thing that you want to know here is that you don't need to use Crunchbase. I have a pro subscription to Crunchbase, so I can automate pulling stuff from the API, which for me is worth it because I've built it into my scripts when I kick one off. But you can also get this information from just Google and Wikipedia. You just want to try to find acquisitions of the target company. Now, here on the left-hand side, you can see Twitch has, basically been acquired by Amazon in the left-hand screenshot here, and then they have 4 acquisitions, and it gives information on their founders and everything like that, and it gives you info on their Facebook and LinkedIn and Twitter, which could become useful later on. But we want to drill down to the acquisitions, and here you can see that Twitch has acquired 4 companies over the last 6 years. Revlo, the most recent, Clipmine, Curse, and Good Game. So these may or may not be in scope for your program. It's important to check and see if they're in the out of scope clause and if they're in the in scope clause. If it's a wide scope program like Tesla or like Verizon Media, and it's it's not an either, but you've confirmed that they're acquisitions of the company, you might feel safe, submitting vulnerabilities for these domains. And you would drill down into Revlo or Clipmine or Curse or Good Game here and find their main domain, which is probably Revlo.com or Clipmine.com or Curse. I can't remember. Curse was curse.gg. These may not exist anymore. They may exist, but redirect somewhere else. But they could be good seed domains for us to add to our tools later on. One other thing here is that sometimes, even though you get the acquired date here, sometimes you don't get the divested date here, which means maybe the company has resold or separated from the acquisition. So always do some Googling at this point to see if that acquisition is still acquired for the top company that you're actually hacking. So this is one of my favorite sites. Talked about it in previous talks, so won't spend a ton of time on it, but bgp.he.net, Hurricane Electric Internet Services, allows a free text form search box to search for the autonomous system number of a organization. So here I've just put in Twitch, and immediately I can see that I have 2 autonomous system numbers, which are top level numbers given to an organization when their network gets big enough, and it encompasses all of the known IP address that they have. It doesn't represent things like cloud assets like AWS and GCP and Azure, so it's not a complete picture of Twitch, but it is a starting place where we have some ranges of IP space, both IPv4 and IPv6, that we can check out here. We can also see that their description name, and probably what is also in their registrar information, is they're listed as Twitch Interactive Inc. right now. So this gives us a lot of place to start for looking into this company. So a lot of people, want to automate a lot of portions of Recon, and that's absolutely cool. So if you want to do some ASN enumeration on the command line, there's 2 tools here that you can use. One is MetaBigor, I think I'm saying that right, by Jesse JJJ, which will fetch ASN data from bgp.he.net and asnlookup.com. And you can see the syntax for that up there. You can also use a tool called ASN Lookup by Yassine, and that one pulls from the maxmine.com dataset. The one problem is pulling ASN data like this without having that contextual lookup on an actual web page is I've been burned a couple of times where I try to automate ASN lookups, and because of the term I put in this case like Tesla, or if I put in another term that I'm looking at for a business, even if I were to just put in Yahoo or Verizon, I could get back multiple different things. For instance, in this case, Tesla, if you're not careful, you could get back other companies that have Tesla in their business name, and not exactly Tesla Motors. So you have to be careful with automating some parts of this, although this one actually goes pretty well in the automation here. I'm pretty sure these are their ranges and everything would be good. Yeah, that's why I normally start my process with manually doing it through the bgp.he.net site, so that I make sure that I don't accidentally kick off Recon on a whole bunch of stuff that's not even in a bug bounty. So just a little warning there. So after that, I move into enumeration of the ASNs. And so right before us, we had a wonderful session with Jeff Foley, who is the lead project owner of the Amass tool. And I use Amass extensively in my Recon for multiple different things. And so Amass is separated into three different tools. One is Intel, one is Enum, and then there's a couple other ones. Actually, I think there's more than three tools now. So you can feed Amass Intel with an ASN number. Here you can see that Twitch Interactive is AS46489. And what it'll do is it'll go out and scan that IP range. It'll expand out all the ranges, and it'll scan that for top level seed domains. And so we can gather more seeds here. And you can see that now we're starting to expand our scope kind of exponentially. The more seeds we get, the better, because then we do subdomain enumeration on those seeds, and we do all of other recon on those seeds. And so the more seeds we have, the better. So here you can see that inside of a range that we verified as them, Twitch Interactive, and their IP space, we now know that they have some stuff that we didn't know about at all. We have Justin.tv, which is the company Twitch used to be. We have TTVNW.net, which I have no idea what that domain really deals with at all. We have Twitch.tv, which is their main domain. We have TwitchCon.com, which is a domain probably for their conference, and then SocialCam, which I had no idea was related to Twitch. So now we have more seed data to add to our mind map. So the next section of kind of wide-scale recon is reverse whois. And so there's a lot of reverse whois sites out there on the internet. The one I happen to use because it's cheap and has a database that I don't know, I've just gotten used to, I guess, is called Hoaxi. And Hoaxi will basically let you search a domain, twitch.tv, and you probably all used reverse kind of or whois lookups before. All it does here is it pulls up, who has owned Twitch TV in the past for, all of the years. And here you can see that at one point the company name and the registration data was Justin.tv, and the email address was domainmaster@justin.tv, and then now the owner is Twitch Hostmaster, and the company is indeed Twitch Interactive Inc., which we saw in the ASN, and then the email address is hostmaster@amazon.com. And then there's little sections right next to it that basically you can click on and find if you own an API key for this. You can click on and see all of the other related domains. So you can see there's 575 for Twitch Interactive and 20 for Justin.tv that other sites have used the same company name or something like that. And you could also drill down into the registrar email. This is basically what reverse whois is. Now, you can get a free API key with Hoaxi, which gives you, I think, monthly free credits. There's some places that you can find on the internet that do this for free, but only give you back a subset of the data. So you have to find your own flavor of reverse whois. And this is like medium fidelity data, I like to call it, right? So what this will include is, a site like Twitch will obviously go out and park a whole bunch of domains. So just because something's registered under Twitch Interactive Inc. or Justin TV doesn't mean that it actually is an application or a website. It could just be parked and redirect somewhere else, and may redirect to something that's out of scope. So it's important to mark these, but verify them when you land someplace from them. So there is a tool to kind of automate some of this. I've used it before. It's called DomLink by Vincent Yu. It still works for me. And the cool thing about DomLink is that it will recursively go through all of the Hoaxi output. So you give it your API key, and then you give it your domain, and it will go out and ask you if you want to find everything for these email addresses or this company, and then it'll give you a file that says these are the domains I can find that are related. So this is a pretty cool tool. I've used it in different parts of my automation before. I know that some people are saying it's pretty buggy. I haven't had any problems with it recently. So yeah, I think DomLink is pretty cool. The one feature it has is that it's recursive in looking up all the sites. So an API will give you can give you a list of everything off of one of the sites, but this one will visit the associated sites and also look at their organization names, and if they're different, ask you if you want to traverse those. And so the recursion here is good because it'll just keep going until it doesn't find any records that it thinks are related to what you're looking for. So another piece of analysis I do is on ad and analytics trackers. And so I use Built With for this. I think it's really the only one that the only thing that does this that keeps this kind of data. But Built With is a site that basically does technology profiling and tracking of sites all across the internet. And so you can log in and create an account on builtwith.com and enter in a domain. And here I've entered twitch.tv, and it will give you a whole bunch of tabs. It'll give you the technology profile, which we use way later on in the process. But it'll also give you this tab called relationship profile. And inside of the relationship profile is a listing of all of the ad and analytics tracker codes that twitch.tv uses. So there are Google Analytics code, New Relic, all kinds of different ad and analytics codes. And so you can look at this table, and immediately it has relationships of the ad and analytics code. So it's hard to see on the bottom there, but some of these sites use the same ad and analytics codes as Twitch.tv, and so they could be potentially related to Twitch.tv and could expand our scope. So, for instance, some of the bigger streamers get custom domains that are owned by Twitch, or there might be like some top level seed domain that we didn't know about, but is using the same codes. And so, you can see if you look down there, it's hard to see, but you can see manversusgame.tv. I'm not sure if that's produced by Twitch or not. I'd have to take a look into it, but twtc.tv is I think Twitch, and so there's a whole bunch of related domain information here. So yeah, a lot of stuff to parse through here. You might be able to find some new seed domains in these relationships. There's also a Chrome extension that can give you this information from BuiltWith that you can put into Firefox or Chrome. So yeah, pretty good. So the other things that I like to do that find me top-level domains, and this one is actually not specifically targeting top-level domains, but just things with the keyword Twitch in the URL, is Googling the privacy policy, terms of service, and copyright text of the main page. So I would go to twitch.com, and at the bottom there is, copyright 2019 or 2020 Twitch Interactive, and Twitch Interactive Inc. And so you just put that into quotes into Google. And then I also added an in URL tag that just says Twitch, and I start to get back, subdomains, mobile app that obviously they have, and if I scroll down into these results, I can possibly get more seed domains. So I'll use this on the site to try to glean more stuff. Next, we have Shodan. And Shodan is a tool that's like an infrastructure spider on the internet. It goes out and finds domains and infrastructure and basically resolves them and caches the response and the header. So it's much more powerful than a regular web spider. It catches cert data and it does some stack profiling, and then it puts it in this giant database, and it's always scanning. And so a lot of hackers have used Shodan to find a lot of IoT stuff that's been left out on the internet and unsecured, and it's a really cool tool. Shodan's awesome, and so every once in a while they have a great sale on keys for Shodan. You can go grab a Shodan API key for pretty much nothing. Now, here I've searched twitch.tv, and I've gotten back some results on sites it thinks are related based off of probably the keyword Twitch or the fully qualified root domain twitch.tv. So I can see that the top result is twitch.com, and it gives me some information that I kind of already know about, right? The domain is twitch.com. It has a pretty standard IP address inside of their IP range. But down at the bottom, I see a result coming back from Turkey, and I don't exactly know this one's from Ireland, Dublin at the bottom, and in the common name of the certificate, I can see that there's a common name that says twitch.amazon.eu. And so Showdown can really bring you some interesting stuff to ask some questions, right? Is twitch.amazon.eu, is that something that, could be considered in scope? I wouldn't think so because it has an Amazon domain, but maybe it's part of Twitch's infrastructure because they're owned by Amazon. So something I'd have to test, right? When you go further down into these results, when I did this last time for Twitch, there's some headers that you get alerted to that Twitch is using, and I wanted to know what those headers are for, and so it'll start to prompt interesting questions around infrastructure and things like that. All right, so now that we've found a whole bunch of seed domains and related information about our target, in this case, most of the examples have been Twitch or Tesla, we're going to move on to enumerating subdomains for those roots or seeds. And this is a big part of our analysis. Our analysis on subdomain enumeration will use many different tools and many different techniques that we're going to walk through in some of this. So for subdomain enumeration, really we have a couple different types, and so the first type of subdomain enumeration that we'll do is linked and JavaScript discovery, and then we'll do some subdomain scraping, and then we'll do subdomain brute forcing. And there are some auxiliary kind of things, which I just have the plus plus box down there, that we can do to enumerate more subdomains that don't really fit into either of these boxes or any of these boxes, but we'll talk about those as well. So the first part is linked in JavaScript discovery. So link discovery, this was the first workflow and still a workflow I use a lot of the time to find linked assets or links inside of a site. I use Burp Suite Pro, or I used to use Burp Suite Pro, and now there's some other ways to do this, which I'll show in the next couple slides as well. But basically, the steps for doing link discovery with Burp Suite is what we're trying to do is visit a seed or root and look at all the links on the page that are contained within the HTML source and the JavaScript and examine those links. And that'll happen in Burp Suite. So you can just visit, a site, and Burp Suite will fill up with everything it sees that's linked on that site. And then we can do some fancy filters and spidering to recursively find even more assets that are related. So this is a hybrid technique. So this technique will find both roots, seeds, and subdomains in its output. And the basic thing we're going to do here, which we're going to show, is we're going to turn off passive scanning in Burp. You can set forms to auto submit or set them not to auto submit. It just depends on what you want to do. A little bit more dangerous to have them set to auto submit. Set your advanced scope control, which we're going to show a picture of, and a keyword of your target name. And what's important here is we're not going to use a fully qualified domain name. We're just going to use a keyword. And then we're going to walk the main site and spider it. And then we're going to spider all the hosts that come out from our filtered view. And we're going to do that recursively until we have a big list of things. So here on the left-hand side of the screenshot is just one visit to twitch.tv, right? Just the main page of twitch.tv, and it's going through Burp. And here on the right-hand side, you can see that the site tree in Burp, or the sitemap in Burp, has filled up with every link it sees that's embedded on that main page, which is a lot, right? Twitch has a lot of functionality going on. So you can see, a lot of this we don't care about, right? What we're trying to find out is assets that are related to Twitch. So it's good to have all this data, but we need to filter it down a little bit. So next, we're going to go into our Target tab and our Scope tab, and we will click the box that says Use Advanced Scope Control, and then we're going to add a scope role. Where it says host or IP range, we're just going to put a keyword in there, which is Twitch, and this is why we need to use Advanced Scope Control, because this allows us to use a keyword here. Now we're going to say OK, and then we go back into our sitemap and we click the ribbon bar where we normally would say show only in-scope items, and we'll check the show only in-scope items. So now what this will do is it'll take that giant site map that we had with all the stuff we don't care about it, and it'll only show stuff to us where it sees that the word Twitch is in the URL. And so this is what we get, right? So this is pretty good. Just from visiting the first page of Twitch, we can see we have api.twitch, app, blog, client event reporter, clips, et cetera, et cetera, et cetera. And this is expanding our domain pretty well, right? Anything that has Twitch um, in the URL is showing here. Now what we're going to do is we're going to select all of these with a Control A, and we're going to spider these. And so that'll send the spider out to visit each one of these and to look at their home pages and find if anything returns that has Twitch in the URL as well. So you can see that doing something like this, um, the selected ones that we had were in this orangish color, and the white ones are new things that we found from our spidering. We've only been doing, in this example, I'd only been doing it for a couple minutes. So you can see here we found a ton of new domains from spidering everything. And this is the first set of spidering. And you can do this over and over and over again. And here you can already see that we've already found some new roots in this data, right? So before we didn't know about twtchapp.net, Twitch, the shortening of Twitch app, ext-twitch.tv, twitchsvc.net. So we've already started to find some more roots. We found a whole bunch of subdomains in here. And we know these sites are live when they turn black, and Burp has actually managed to visit them and not just observe them in HTML source. So yeah, there's a ton here, and this is the next iteration of this. You would select all of these again, and then spider again until you got no more results. Now this used to be the way I did it throughout my whole pen testing career. It was, a pretty normal process. But there are some other ways to do it. The problem that comes with using Burp Suite Pro to do this is like, how do you get this data back out into other tool sets? And it's very clumsy. So you have to have Burp Suite Pro, and you select everything once you're done with your recursive spidering, and you click on Engagement Tools and Analyze Target, and then you export the Analyze Target PDF to your desktop, and then it gives you an HTML report which you can either parse, or you can just open the report and um, drag and select all of the targets in there, and the targets are all of the domains basically. Yeah, pretty clumsy to get the data out of here. So we would want to maybe see if we can do this, in an automated fashion on the command line. Luckily, there's two tools which I think are awesome. And if you think about what this is doing and what we need to do this, we really just need a spider that can recursively land on things and parse out links from them, right? And then from there, if we see a whole bunch of links or subdomains or things like that, we could probably use Bash to pare down what we wanted from that information. So in link discovery, you can also use, two tools that I really like right now, which one is called GoSpider by Jesse JJJ. And it's just a generally well-rounded spider. It can do a lot of stuff, and here you can see it's the left kind of grayscale image here, and it'll separate out everything. So I can run GoSpider to twitch.tv, and you can see it parses the robots.txt. It starts parsing out subdomains. It'll give me verbatim URLs and endpoints. It will give me JavaScript files, and they're all nicely notated. Yeah, so and it'll give me status codes for URLs that it does visit. So it will give you back a lot of stuff, and then you can parse, using regex or grep or whatever you want to do, and start pulling this stuff out. Now, what you want to do, what you need to do here is you need to add that recursion in. So you need to code the recursion yourself in something like GoSpider, I believe. Now another one is HackCrawler by HackLuke, and HackLuke is awesome, and I think he'll probably be around today, maybe. I'm not sure, the time zone's weird, but HackCrawler is also another crawler that does similar things, but has a lot more strategies in the parsing that are interesting to bug hunters, and I believe it has recursion. So these are two things where you could implement this link discovery process on your own on the command line. And so I try to give a lot of options here for people who are manual and tactical. You want to do it manually, or people who want to work on the command line and script all this together into a giant Recon framework. You have a lot of options here. And these are the two most stable ones I've seen with kind of command line spiders so far. So these are awesome. Another one to find subdomains is this tool called Subdomainizer that I've used before by Neeraj Edwards, and I really like this one because it has kind of a special feature which I really appreciate and I think is kind of forward thinking. And some other tools are starting to do it now, but it was the first one I saw do it. And so subdomainizer basically will you give it a URL and it will go there and it will find all JavaScript files referenced on that URL, and then it will visit them and it will start parsing out subdomains, which is great. It has some good parsing logic for getting subdomains out of JavaScript files. It'll also separate out cloud services that the site might be using. So on the right-hand side, you can see that, Twitch uses CloudFront, and then it also has a feature to detect what it thinks are maybe API keys or leaked anything that's leaked that kind of looks like a key of some sort. And it uses the Shannon entropy formula to find these potentially sensitive items in all the JavaScript files it goes to. So here you can see in the left-hand side two keys that showed up that I could go back in my burp traffic or back in the crawler traffic and try to find out where these came from and to see if they're sensitive keys hard-coded in JavaScript, which is pretty common finding sometimes in bug bounty programs, unfortunately. Um, if you're just looking for subdomains and you're not looking for this algorithm or this formula, the Shannon entropy thing to find keys, there is another tool called Subscraper by Cillian Collins that might be better because it supports recursion. So not only will it take the first page that you visit and grab all the JavaScript files from there, but it'll take subsequent pages and scan. It'll kind of do like a light spider and scan those and find domains from those pages. But again, it doesn't have the key finding that subdomainizer has. So now we've done some analysis of JavaScript. We've done linked discovery and basically pulled everything out of the HTML source that we could find, and we found a whole bunch of subdomains and maybe some potential new routes, and we could feed those routes back into the subdomain enumeration process. And remember, this is an iterative thing, so you'll end up going forward and then taking some new information and starting again in the recon flow, which makes it somewhat hard to sometimes script and build a tool set out of, but a lot of people are getting there, which we'll talk about later. So subdomain scraping is the next iteration of tools that we're going to use to find more assets or more subdomains. And remember, the more we find, the more we have to look at, the more chance we have to find a bounty, right? So subdomain scraping sources are the crux of the next two tools we're going to talk about. And there's all kinds of sources out there on the internet, right? So there's like a whole bunch of sites like Netcraft and RobTex and DNSDB and DNS Dumpster, which are basically websites that house databases of URLs or domain information. And it's for IT purposes. It's not really for hackers or the Wayback Machine. And then there's other types of sources too. There's search engines. We know Google and Yahoo, Baidu, Bing, Ask. These are all search engines that people use, and they also have data sets that they're holding that we could ask if they know about subdomains related to Twitch. And then we have like these certificate projects like cert.sh and CertSpotter and cert.db. And then we have like security sites like HackerTarget and Security Trails and VirusTotal. And these things are all doing projects related around security. But in the end, they have a lot of URL or domain information in these sites, and they have searches that we can do to look up our domain. So we might not be using these sites for exactly what they're meant to be used for, but we're going to take advantage of all of these sources to try to find subdomains based on, in this case, twitch.tv. So there's new sources coming out all the time, right? This is not an exhaustive list. This is actually a very small listing of sources, and some of the ones we're going to talk about aren't even in some of these boxes here, and I'll talk about the tools and stuff that parse out these sites or that visit these sites and parse out our domains that we want, our subdomains. So this is just an example of using Google for this, right? So Google's a search engine, and you can give it the site operator twitch.tv, and that'll return only sites that are twitch.tv. And then on the first page, you probably get back www.twitch.tv. So you can add a minus www.twitch.tv, and then you won't get that in the output. And then you'll find other stuff like watch.twitch.tv and dev.twitch.tv. And you can iteratively minus out all the new ones that you find until you don't find anything else, and then that's pretty much everything Google's ever seen as far as subdomains for twitch.tv. So this is the way that you do it with search engines. This is how you iteratively pull out all the subdomains that Google knows about twitch.tv, and there's other ways that you can do it with all the other sites. They're all different. So each one is a specific piece of technology that has to be written or code that has to be written to go scrape the service. So Amass, and we just got out of an awesome workshop with Jeff and his team about Amass, is pretty much the one I use for a lot of stuff inside of my Recon workflow. So for subdomain scraping, there's two front runners, Amass and Subfinder, and I use them both because between both of them, they parse a lot of the same sites, but they also have a couple of variances in what they can do. And so in my workflow, using both of them in automation, I just kick them off at the same time in a script. They go off and do their thing. They don't take too long, usually anywhere from 2 to 10 minutes to go gather all of the subdomains for the root or seed that I'm looking for, and then they'll come back and give me the output, right? So Amass has the most sources I'm pretty sure that it's looking for, and you can go, and all these slides are hyperlinked, so when I send them out, you'll be able to click on here or just Google Amass, obviously, and it'll tell you what sources that it uses, and so will the Subfinder page. And it also has like extensible output. It gives you brute forcing options. It does permutation scanning, which we're going to talk about a little bit. Has a whole bunch of other modes, and basically Amass is just kind of awesome. So here on the right hand side, you can see I'm just using Amass enum in this case, I think, and this might be actually an old screenshot, but I might be using Amass enum here just to look for twitch.tv, and it's going out to all of these sources like we talked about and pulling back subdomains that it's seen in those websites, or those websites have seen, and giving us all back a list. So Amass also, and I say Amass and Amass pretty interchangeably. I don't know why, but Amass also will give us this nice little table at the end of the run. And I really appreciate this table, and I use it a lot because what it'll do is it'll say, okay, I've discovered, in this case, 439 names, and they came from these sources, and that's great. And then it'll tell us where these names were in an ASN, or what ASN they came out of. So you can see that something like 60 something came out of a Fastly ASN, and you can see that a ton of them came out of Amazon, which makes sense because Amazon owns Twitch. And then you can see that there's also an ASN for Justin TV. Now I'm not sure if I had that, in my ASNs list. I think I did. I think it was the first one I had. But you can see most of their infrastructure resides in that ASN, Justin TV, Twitch Interactive. And then there's some other stuff hosted in Amazon, a couple of services that are forwarding to Bitly. They have one site which is using Google. And this is just a good overview of kind of the technology they're using, the cloud technology that they're using, or the third-party services they may be using in all of these sites that we've discovered. And so, here I've definitely found sites that have landed in ASNs that I didn't have in the beginning of my testing. Not specifically with Twitch, but other sites when I'm doing bug bounty in a wide scale bug bounty. So you can feed these new ASNs that you found in this table back into Amass Intel like we did earlier, and find all of the top level seed domains, and then start the whole process over. So like I said, it's a iterative process. So some tools will give you back new stuff, and you send seeds back to the beginning of the workflow, and you do subdomain enumeration for them, and you scan their ASN, et cetera, et cetera. So iterative workflow. So the next tool to do the subdomain scraping is Subfinder. And Subfinder was originally written by Iceman and Michael Skelton, who's better known as Codingo. And he's an awesome guy, and so is Iceman. And recently it's been taken over by a group called Project Discovery. And Project Discovery has been doing some sick tools lately, trying to retool a lot of stuff in the Recon world, and they've also built a framework that I think they're releasing, excuse me, later this year, which is actually really cool. So Subfinder incorporates other sources and has extensible output, is really stable, and so I use both Subfinder and Amass in subdomain enumeration for subdomain scraping. So this is, I'm not sure it's like a secret, obviously, but it's definitely one of the things that has been making me a lot of money on bounties recently. And this is Gwendol Lecuic. I'm not sure if I said your name right, your last name right, Gwendol. My bad. But Gwendol basically made a whole repo around GitHub enumeration. And one of the tools he made is called GitHub subdomains.py. And this thing is amazing because what it does is it goes out to GitHub and you give it your GitHub token for your personal GitHub account, and it will do just a search for twitch.tv in the GitHub search. And then it will parse all of the results that come back in code and parse them into a list of subdomains it sees for twitch.tv. And so GitHub inherently is like the bucket of the world, right? There's so much code in GitHub and so many developers who have probably worked with Twitch or for Twitch, and maybe it's not even like a secret that these, subdomains exist, but they're definitely not referenced anywhere else. And I find stuff using this script that I have not found anywhere else. So the original run of GitHub subdomains here for Twitch gave me 1,828 subdomains, which is a lot. What I did notice though is that in that 1,828 that it found on Twitch, a lot of them were custom branded subdomains, right? So if you think about Twitch, the streamers, sometimes when they get big enough, I think you can get like a custom branded subdomain. And so all those custom branded subdomains in them had this term .tmi, or like name of the streamer .tmi.twitch.tv or something like that. So I just took the output of this and catted it through grep and took out all the TMI domains, the .tmi ones, and then these were the ones that were not player based. These were the other ones, so Usher and Clips and Player and API, et cetera, et cetera. So this script is awesome. I don't know if a lot of people are using it. It's been out for a long time. He wrote his original set of GitHub tools a while ago. I just discovered it this year, and I've been using it, and I feel like I'm finding all kinds of domains that other people aren't finding using this source, right? This is a different source, GitHub, which people are not using. The whole repo is actually epic. So he has other tools that can do GitHub dorks. A whole bunch of searching. You can find email addresses from a repo or from a related term. There's a whole article. So if you click on that link that says GitHub search, it'll take you to this script. But if you back up one into the repo, there's a whole bunch of scripts and an article that he wrote on Medium or another site, one maybe his own personal site, about how he uses it. He does a GitHub enumeration. It's absolutely awesome. Now, the thing about GitHub subdomains.py to find subdomains related to Twitch or anything else is that the GitHub API is kind of wonky. So it will return random results and is rate limited every once in a while. So when I bake these into my subdomain finding script, which I call Hunter, I basically run it about I think 5 or 6 times, and I add a sleep in there between each run. So I do I think 5 iterations with a sleep of 6 seconds because I think that's around where the rate limiting is, and then the last one I wait 10 seconds, and then I do one, and I basically take the output of each one of those runs and dump it to a file, and then when it's all done, I unique that file. I cat it out and I sort it and I unique it. And then that gives me pretty good coverage and some consistency from running the tool because you can get, API rate limited. So, if you want to be super safe, you can increase those sleeps a little bit longer, right? I'm not in a hurry when I'm looking for subdomain enumeration. I have plenty of stuff to do when I start a project. So I can let this run in the background. I don't have any problem if it takes 10 minutes to enumerate all of the subdomains for a site using all my tools, or I do start to get a little antsy when it takes like 20 minutes or something like that to run all of my automations. So, set your sleeps as, high as you can to avoid rate limiting, but as low as you can to, like not make your iterative runs of this bad. And like I said, you take the output and you cat it all to a file, all those runs, and you sort and unique it at the end. So the next one that I've been using to great success, and the ones I really like, obviously I put this little fire icon in the bottom right hand corner, is this one, which is called ShowSubGo, and it is a parser for Shodan, right? Which we mentioned earlier that we can get some information from. But this is a command line tool that will look specifically for subdomains based on a seed like twitch.tv or a root domain. And this is written by Incogbytes, which is awesome. And the reason I use this one, and there's several of these types of tools out there, is because it seems to be the most stable and gives the most output. And so it's also written in Go, which is well managed coding language, etc. So this one, you see, I ran it here, and I basically give it my domain and then my key, which is blurred out there, and it gives me back a whole bunch of stuff that showed in a scene related to twitch.tv. So this one has been very great for me in testing, and along with the GitHub one. It gives me, kind of a little bit of edge in the subdomain scraping kind of world, I guess. Now, the next one is scraping cloud ranges, and this one is kind of the level two or like kind of the higher echelon of what a lot of bug hunters are doing, like that are pretty successful, and uh, I'm pretty sure all of them now have either built their own tools or subscribing to a tool that is doing this technique. And so, it's not the first time anyone has mentioned it, but it's not exactly plug and play run a tool type method. What this is doing, or what this basically technique is saying, is going to all of the AWS, all the cloud ranges like AWS, GCP, Azure, and all of those huge ranges is scanning them every so often and looking for only port 443, which is SSL, and connecting and looking at the SSL certificate and seeing if our term twitch.tv is in the certificate data. And so, invariably, especially for Twitch here, they will spin up a dev site or some like single shot site, and they'll not promote it, and they'll think it's private and security by obscurity, et cetera, et cetera. And so they'll put something out on the internet that isn't in any of our other sources, but because we're doing this proactive scanning of all of the ranges for all of these cloud services, and we're looking at the SSL certs for twitch.tv, and it hasn't filtered into something like the certificate repositories yet, we'll find this before anybody else, and several companies have made lots and lots of money off of this. And so you can build this tooling yourself. You can build it with masscan and nmap, and you can cron job out those scans, and that's what a lot of people are doing. And you know you could do that yourself. And there's a wonderful article out there by Dahi Park which outlines kind of building this yourself. There's also, luckily, last DEF CON, Sam Erb did a wonderful DEF CON talk on this whole process that he did, and he created a service called bufferover.run, which queries the ranges every week, and then you can just query this service, and it will give you back whatever it knows from the last week. And so this is what I use right now, although I do have access to a service that will do it on command, and building my own boxes to do it right now. So this is kind of the next level of scanning it proactively. Now, you can query here. You see I've queried twitch.tv or .twitch.tv in the query string where it's outlined in red. And then I have to parse the results with JQ and then do some other bash foo. And then I get a list back of the domains related to twitch.tv, which some of these, were definitely not in the other data that I've seen so far. So that's awesome, and a tool. You can see in the right-hand corner, I've represented kind of the ones that are really finding good stuff for me with a little fire icon. So now that we've done subdomain scraping throughout sources that I think are valuable. AMAS and Subfinder are doing a ton of different sources, and then we've added some ones that are kind of bespoke. Now that we're done scraping sources, we're going to move on to subdomain brute force, which is kind of one of the last pillars of subdomain enumeration. So subdomain brooding, at this point, we're guessing for live subdomains. So we're just going to, try and resolve, something, at twitch.tv, or in this case, in this little example, company.com. And so, usually if you look at something like this, totally does not exist.company.com, we'll usually not get a record. So we can use a large list of common subdomain names and just try to resolve them over and over and seeing if anything succeeds. The problem with this method is that normally we've done this in the olden days with scripts like Fierce and some other stuff like that. Fierce was a really popular one for most of my pen testing career. And it was only using one DNS server at a time, so it took forever to run the analysis on a large domain like Twitch, which has like a lot of assets. So about 3 years ago or 4 years ago, some tools came out that were both threaded and used multiple DNS resolvers simultaneously to do this process. So it sped up the process infinitely. The first one of those was Mass DNS by Blechschmidt, and he was the pioneer of that kind of idea. Now, AMAS has basically implemented this into their tool, and they use 8 resolvers by default, and you can add a larger resolver list with the -rf flag if you want to distribute it even more. So in order to do this, you can just do amas enum-brute-d for domain and twitch.tv, and then here I've added the -source, the -source command, just to show you where the domains are coming from, the subdomains are coming from. So you can see a whole bunch are coming back from cert.sh, and then one came back from brute forcing, and then pulled one from threat crowd and a sublister API, and another from threat crowd, and more at search, and then there's this list was super long. I just took a snippet of it, and there were a whole bunch more that came from brute forcing, etc. And AMAS has its own list built in, so it's using pretty stock kind of generic brute forcing list. And then you can also specify your resolvers if you have more resolvers and want to basically make this process a little bit faster for the brute force. So another one, if you like separating the workload and not just using AMAS to do all of your stuff, there's another tool called Shuffle DNS by the Project Discovery team, which we've mentioned before, who are doing amazing work. And this one actually is a wrapper around Mass DNS, the old tool. And the reason why it's a wrapper around this is that you can basically handle wildcard domains. There's a whole bunch of advantages in using Shuffle DNS here. So if you prefer the Mass DNS core, you can use the Shuffle DNS wrapper and add your own word lists and resolvers, just like a Mass as well, if you want to flip it up a little bit. So a multi-resolver, threaded subdomain brooder is only as good as its word list, really, right? I mean, at the end of the day, you're trying, a list of things, and if you have a horrible list, you're not going to find anything. So there are 2 trains of thought out here for lists, and so you have people who really like to use tailored word lists or build them on the fly, and there's people who like to use like all-encompassing massive word lists for everything they've ever seen. Both of these have advantages. They're both absolute great strategies. They've both worked for me in the past. I released, as part of the Bug Hunters methodology, I think 2, my all.txt file, which was basically every DNS tool that I had ever seen in the hacker world, all had their own word list. So I took all of those, and you can see the list of the files on the right. And all of those lists for those tools, I just kind of combined them into one massive file. And then I added the common speak data that the asset note folks released as well for subdomains. And so it was a giant file. I think it's something like 15 megs of words that it's going to try to brute force. And that is considered a massive word list, right? And it takes a while to run. Not too long with the technology that we have with these multi-resolver threaded subdomain brute forcers, but still takes a little while. But that's normally what I use in this phase of my testing. And yesterday, Tom Namnon talked about building custom word lists using a whole bunch of awesome tricks, and he released some cool tools around around that as well. Specifically, I loved his little like Google Scraper extension, which was awesome. Tom Namnon is one of the guys that I suggest you just like follow everything he does. He's super smart, great person, and yeah, I love the guy. So yeah, so he released a talk yesterday on who, what, where, when word list, and he talked all about this idea of tailored word lists or um, kind of custom word lists. And so I highly suggest you go back on the video yesterday if you didn't see it and watch his talk. There was also a tool that did this recently. I know I bookmarked it somewhere, but there was a new tool that basically parsed keywords on a web page. And I can't remember the name of the tool. If one of you wants to paste it in chat. Cool was the first one to do this, but I know that there was a new one, CEWL. I know there was a new one that came out that I think I saw on Twitter. But basically parsed keywords from a web page and tried to build a customized word list based on keywords, right? So since we're testing Twitch, probably a majority, not a majority, but like some of the users who or some of the domains might be related to Twitch infrastructure, right, and have Twitch keywords in them. So if you parse the site and you break it all down and you make a custom word list from terms or words that might be related to Twitch, and then you turn that into a word list for your DNS subrouting, you might find something. That is the general idea there. So I can't remember the name of that tool. Hopefully somebody can find it. Somebody like Security who's just like he's got his finger on the pulse all the time. So for subdomain lists, there wasn't like a ton of iteration going on. It kind of stayed the same, generic brute forcing words, and some people were, putting out some data. But the first team to really iterate on like a new type of list was the Asset Note team with their Common Speak data, which they use Google BigQuery and a whole bunch of data sites like Reddit and some other places to parse out subdomains. And so their first collection, Common Speak 1, was included in the all.txt file, but only version 1. They a year or two ago they released version 2. And so you can grab that at their GitHub repo. So Asset Note Common Speak 2, and that has a second run and some more sources where they parsed out subdomain name and URL data and all kinds of cool stuff. It's a really cool project, and they're really iterating on the idea of massive lists there too. So the next thing is now we have some brute forcing, and we have scraping, we have brute forcing, we have analysis of JavaScript. We've got all kinds of sources to find us subdomains. The next one is alteration scanning. And so this is the idea that a company has like dev.com, and then they might have like dev1.com or dev2.com or dev-1 or dev-2 or dev.1.company.com or dev.2.company.com. And so applying these alterations or permutations, sometimes people call them, to common words when you're brute forcing is a method to find subdomains, and it's a pretty valid method. A lot of people find some cool obscure stuff with this method. Now, this method was kind of first pioneered, at least I know, by Nafi and Shubs. Shubs, as part of the Asset Note team, and Nafi is just an awesome bug hunter and pretty cool dude. And they wrote a tool called AltDNS, and that was kind of the first one to do this. Permutation scanning or alteration scanning is now also included in Amass, and yeah, and so I can show you some like experience of where this has helped me in the past. Not only find obscure subdomains, but do some other stuff as well. So I just grabbed some of the instances that I had in the last couple years, and I had some projects where I had a web application firewall on both of these projects. And so the target or the organization had the WAF enabled on www, but because I had used a permutation scanner and I'd found www2.target, I was able to bypass the WAF because it wasn't enabled on that domain, and I was able to do SQL injection there. And another one was I was just trying to test generally in Spider, and I was getting blocked by Akamai. And one of the permutations I always use in all my lists is origin. an origin sub, because what I want to look for is someone who has predictably named their Akamai origin server, their CDN origin, and the permutation scanner, if I give it that term, will come up with a whole bunch of permutations. And if I find the right one, I can bypass filtering and go to the source. So these are two instances where this has absolutely worked for me. In different cases, I've also just found really obscure subdomains with alteration scanning as well. So now kind of the other category is just like a whole bunch of things that I think go into Recon that don't fit anywhere, right? I mean, they could be getting us subdomains, they could be getting us other stuff. Some of them bleed into vulnerability analysis, but we put it in the Recon version of the bug hunters methodology because we do them at a mass scale instead of digging into one site. So we're just going to talk about some of those things that I use here. So eventually I'm going to do, after I get all of these domains and subdomains, right, I'm going to have to, or I want to port scan them. I want to find, first of all, I want to find obscure web ports, right? Maybe web services or websites that are running on ports other than 80 and 443. So a port scan is going to be needed to find those. And because you've already seen how massive and how many subdomains and how many seed domains I have and how big this type of a project can get for a big company, um, I'm going to need something fast. And so the most, like most hacker education would have you use Nmap right about here, right? They'd be like port scan with Nmap. But actually, the workflow is more use something faster and quick, and then once you find out stuff is up and there's ports up, then you can feed that to Nmap. So the tool that we use here is MassScan by Robert Graham, and it's much faster in that general kind of just finding open TCP ports. It doesn't do any of the fancy like Nmap scripting engine or version analysis or anything like that. But when you find out the port's open, just with something like this, then you can feed the open ports to get scanned in Nmap to do the fancy scanning, and that's what I do in my tool chain. So you can basically scan way faster in MassScan. It has a rewritten TCP/IP stack. It's got multi-threading and is written in C. It's probably the fastest port scanner out there, I would say. Maybe there's some other ones, but it's the one I've been using. So syntax is pretty simple: MassScan -P1 through 65,335, so the whole range, and then you can take a input file of IPs, and so this is one of the things here is MassScan only scans IPs. It won't scan domains. It won't do the resolution for you. So you have to have an IP list, not a domain list, which a lot of our tools and a lot of the data we've amassed, sorry, but a lot of the data we've gotten are domains or subdomains, and so we're going to talk about that in a second. But then you can set a max rate. I usually hover around 1800, and then you can set an output file of OG, which will give you a log, and it will give you, and then you can do OA as well, and it'll give you like an Nmap output file. There's a whole bunch of outputs it does, and it can do an Nmap output file, which we can use later to great success. So the full syntax of MassScan, the README is somewhat in depth, but Daniel Miesler, who is one of my best friends in the world and just all around awesome human, and he does some great infosec research. He does these study pages where he just like breaks down a tool into like a very succinct guide. He did one on MassScan, and it shows all of the different ways you can use MassScan. And I highly suggest you check that out if you're going to be using this in your Recon. So we talked a little bit about that MassScan only does IPs, right? Which a lot of the data that we have is not IPs, it's domains. And so restating, I'm not exactly how you say that, but this person made a tool called DNMassScan, which basically adds the ability to do a resolve on a domain, get the IP address from it, and then pass that to MassScan. So it's a wrapper around MassScan. You need MassScan installed, and then you can see you basically give it. You can send it a list, or you can give it a single domain. But here, the user has given it a list example.txt. The output's going to go to a file called DNS log. He's looking for port 80 and 443 only, and then setting an output file of masscan.log. And so the first thing that this script does is it will resolve the domains into the dns.log folder, and then have masscan scan everything in the DNS log folder. So if you cat the DNS log here, you can see, GitHub. These are the sites that he had in that example.txt file: GitHub, restdating.github.io, and Google. And so then you can see that it scanned all of those IPs for ports 80 and 443, and that's the general output of masscan right there, which is parsable um, by grepping and or awk or set or something like that. So this is a good way if you don't want to write a wrapper of your own. I wrote a wrapper of my own, but I might be replacing it with something like dnmasscan. So yeah, good way to get around that limitation. So once we have everything from a couple steps ago, we'll have a whole bunch of output files from port scanning. And if you do mass scan and you then output it and then you use OA, which gives you all of the outputs that normally Nmap will give you. It's a weird feature: mass scan outputs, Nmap output. You can use the Nmap OG file and pass it to this tool, which will do service scanning. This is the next thing we want to kind of do at a wide scale. So we want to take all of those remote administration protocols like FTP and SMTP and SSH and Telnet and just run a small brute force word list, mostly default passwords like admin admin or blank blank or root root. There's a small list in this tool called brutespay by Sneaksnick. And this will go out and basically take all of the output from our previous tools and identify the ports, that these remote administration protocols are on from that output, and then it'll do a small brute force with Medusa across all of them. And so I've been using this for a long time. I haven't found like a successor to this. If you guys know of something that's cool that does this, but it has found me a bunch of default FTP that had a anonymous login. I've definitely found SSH with like admin stuff on it with admin admin. I found databases on 3306, but other ports as well with default passwords. So a lot of good can be found from just a simple default credential check on all of the remote services. And so this isn't necessarily web. A lot of people forget about this step, but service scanning and doing a small brute force is very valuable. So the next method, which kind of didn't fit anywhere but is still wide scale ish, I would call it wide scale, is GitHub dorking. So, a lot of organizations will quickly outgrow their engineering teams, or their engineering teams will outgrow them, or whatever. Sooner or later, a developer is going to put code on GitHub. It's going to be a developer, an intern, a contractor. They're going to leak some source code that's supposed to be private in a public repo on GitHub, and they're going to forget that they didn't set it to private, or they're going to sync it to their personal repo instead of their work repo, etc. So I built a little bash script to basically, in the spirit of Google dorking, do some GitHub dorking. And so a lot of these came from pre-existing tools, like all of the GitHub repo kind of ripping tools. But I built them into generic strings. So what it does is it's just a bash file. You enter in your domain. In this case, I've entered in twitch.tv, and it gives you a list of clickable links. Hopefully your shell can handle, we'll build these as clickable links, and it'll just open GitHub. If you're logged in, it'll take you to the search query for twitch.tv, and in this case, password or Docker config or pem private or S3CFG, and these are all things I'm looking for. So I want to find the keyword twitch.tv and this keyword in a repo somewhere. Hopefully someone's done something wrong and leaked something online. So I'm not necessarily looking at Twitch's repos, right? These are individuals' repos that might be employees or something like that. So this is a very common information disclosure type vulnerability. It can range from benign, when you find something using one of these dorks that is no longer on the internet or is internal, so there's not a lot of risk, to critical, where something is on the internet and a password is exposed and it works, and or an API key, and there's tons of sensitive data you can find in repos. Um, so you can automate some of this instead of using kind of my GitHub clicking kind of method here with Gwendol's GitHub search repo. He's got some automated tools to do GitHub dorking as well. So I would suggest you check that out. And then a whole kind of roundup of this topic was done by the gentleman who I consider to be an expert in this domain. And so he did it for the Bugcrowd University project. It's called GitHub Recon and Sensitive Data Exposure. I highly recommend checking that out because it's got some great information, probably better tooling than I have here, maybe, and just all around good and smart guy, and gives you examples of stuff you're supposed to look at that maybe you can script up yourself. So GitHub dorking. In my workflow, I'm doing GitHub dorking while my subdomain scanners are running. Um, and so, I start everything off with one script. I've built my own framework to start everything off. I give it a seed domain, usually one like twitch.tv.com. It goes out, uses all the tools we've talked about, pulls in new seed domains, runs on those, does subdomain enumeration on those. And while it's doing the subdomain enumeration, which is usually the longest thing to wait for in the whole process, I am doing this. I am doing GitHub dorking, and a lot of the times that well spent 20 minutes finds me, if not verbatim vulnerabilities, valuable information about how the infrastructure works or other things like that. So the next area that we have is you have a lot of domains right now. We have a lot of attack surface, and you may feel overwhelmed with just kind of opening this up one by one. This is a very contentious kind of model. I don't know why. Basically, when I have a mind map of all of the subdomains I've found, and I know they're valid and I know they're live, I just open them up one by one in a browser. Or I take 10 at a time and I open them up in Chrome. And when I open them in Chrome, I look at it and I'm like, I give it a quick eyeball. I'm like, is this something I'm interested in hacking? Is what kind of functionality is on this site, or on this subdomain? Is it like a redirect or etc.? So I have the eyeball to do that, and I do it manually. I want to do it in the browser because um, I don't miss anything basically. But it can be helpful to prioritize your testing and your large list of attack surface that we've gathered by taking a screenshot via the command line. And so there's several tools that do this. Aquatone does this, HTTP Screenshot does this, and Eyewitness does this. I've used all three, and it's interesting because I thought that Aquatone was doing the best job of actually not failing at taking screenshots sometimes because the screenshotting technologies are based off of headless browsers sometimes or Chromium command line or whatever. But then I talked to Ben, and when we were talking about our experience in Recon, he actually finds that Aquatone doesn't work as well or is less stable than Eyewitness. And then you talk to other people, and they use HTTP screenshots. So find the one you think works well for you. In the end, what it'll give you is a directory of screenshots. One of the reasons I used Eyewitness is because back then when I started my Recon scripts, TomNomNom's HTTP probe wasn't out yet. And so Eyewitness will prepend HTTP and HTTPS and take a screenshot of both, and that does that work for me of adding a domain to it and telling me if which one of those is active. Because remember, we're feeding it a list of domains, not necessarily with a protocol. And so here it'll just try both protocols for each domain, and that was useful to me. So that's why I used Eyewitness to start out in a lot of my testing. But now, before I even get here, I'm using TomNomNom's HTTP probe to verify if HTTP or HTTPS is up for that domain, and only feeding then that domain to or that URL to Eyewitness later. Next on the topic list of wide recon and kind of auxiliary things to do is this idea of subdomain takeover. And I've talked about this before in previous talks, and there's been a lot of tooling that's gone up and down around this topic. But the idea here is that subdomain vulnerability or subdomain takeover vulnerabilities exist when someone basically points or registers a service which applies a CNAME to a service company like GitHub Pages or Heroku or something like that, and then they discontinue their service. And so that CNAME is still out in the wild, and if you go to it, it will basically forward you to a page that then says there's no more service for that. And so a hacker can go ahead and register with that service, the same CNAME, and then they can take over legitimate traffic of one of your former domains. So this is apparent in a lot of places. It's pretty common, decently common in bug bounty, and you can automate this in the Recon flow to look for this because the signatures are literally just error pages that you're parsing for. A great database that many of the newer tools are using to parse out this data is Ed Overflow's Can I Take Over XYZ repo, which has definitions for all of these services and a small tidbit about, if you can take over this, the answer is yes, and how so. And it's a really cool repo. In fact, Ed Overflow is one of the community's coolest ambassadors and really cool hacker, and he does a lot of great work. So really appreciate that repo. So for subdomain takeover, there's two tools that I prefer, and they're kind of related, right? So subover and nuclei. And so subover previously was written as a standalone tool by Iceman, who joined again, we're mentioning the Project Discoveries team, basically. And so subover had the most signatures for subdomain takeover to find these services and CNAMEs. And recently, that's been incorporated into Project Discovery's Nuclei scanner. And so Nuclei is a larger scanning framework. It is part of their overall, I think, what's going to be either a paid offering or something like that. But they're open sourcing all of the small individual components. And so Nuclei has scans for misconfigurations like buckets and subdomain takeover and verbatim vulnerabilities and token leaks, and it can do technology profiles. So Nuclei can really do a ton of stuff. But its subdomain takeover templates are the most comprehensive I've seen at this point in kind of bounty hunting. So I think there's upwards of like 40 or 50 or something like that in the subdomain takeover um, part of the tool. So these would be the ones I would use to integrate that. I would actually spin up Nucleus and just use their template and their checks for subdomain takeover. Although all of their checks would probably be useful. So now I'm going to talk a little bit about automation plus plus, and this is just the idea of like a lot of this is a workflow, and you've heard me talk about I have my own automation, and if you've ever watched me stream, you can see that I have some like really crummy bash scripts that I use to do some of this stuff, and we're going to go through a little bit of some automation helpers and then some frameworks that exist and stuff like that. So one of the extending tools you can use in automation is a tool called Interlace, which I think is awesome. So this is again written by Michael Skelton, Codingo. And what Interlace will do is basically at some point you'll make one of these recon frameworks yourself, hopefully, and you'll notice that not all the tools take certain types of input, or some lack threading, or not all can be distributed across different servers or proxies. And so you have a couple options. You can rewrite these tools yourself, but you can also, if you don't want to do that, you can use a tool like Interlace to help you, right? So Interlace will basically allow you to take a tool that doesn't support something like CIDR input or glob input. Those are usually you're used to using those in Nmap, right? You can scan a whole range in Nmap, or you can scan 3 octets and then put a star, and that's a glob, right? Or an asterisk, and that's glob input. So you can add support for CIDR input and glob input to any tool by wrapping it in Interlace. You can thread any tool, which is amazing, by wrapping it with Interlace. You can proxy any tool, and you can build giant sets of queued commands or even threaded commands to be applied to a set of commands that you build for your automation. So it can do some really cool stuff. Hack Luke wrote a great guide on it. If you click that link down there, this is from his guide. He basically talks about before when he wanted to run Nikto, he would have to write a bash script, right, which would take all of the hosts, that he had in a targets file and run Nikto one-on-one sequentially. And I guess you could have done this with parallels, but it's kind of gloomy to script it up that way too. But this way, he's wrapped it in interlace and he's given it a target file and he said, I want 5 threads, and he's put his Nikto syntax, and now it will thread up Nikto, which is pretty cool. So he has other examples in this file, and so interlace is really one of those tools that'll help you kind of get past some of the deficiencies in automating some of your workflow. So we've mentioned Tom Num Nom, and he was on yesterday with a great presentation about building word lists. And I didn't just want to make like a whole giant section of every one of his tools, because honestly, every one of his tools is awesome. So Tom Num Nom, first of all, great person. At least, I don't know him super, super well, but Tom Num Nom has always been like super cool in his streams and just seems like a chill dude. I use several of these tools to glue together different parts of the methodology. Gron makes JSON greppable, so it's an awesome tool to parse things too. I use HTTP probe a bunch. When I get a list of domains out of all of these tools, it is the middleware that verifies that the HTTP or HTTPS server is up, and I just feed it lists of subdomains and domains, and it will check. So it sits right in the middle of all my automated tooling. He has an asset finder tool, which I haven't used yet, so I need to check it out. He has a Wayback tool. Meg is a really awesome tool. So he's got a ton of stuff. You should definitely check out his repo and any of his streams or interviews. He's also just a Bash ninja. Yeah, check out the stuff that he does. It's pretty awesome. So now I'm going to talk a tiny bit about frameworks, right? And so, we've talked about all these tools, and, I'm leading into the idea of automation. And I use automation when I feel like it's right, and then in other places I'm pretty stubborn and I won't use automation at all. So I'm a weirdo. But frameworks nowadays are pretty prevalent for Recon, right? Recon frameworks. And so if Recon is not really your thing, that's cool. Several hunters or pen testers have open sourced their automation at this point, so you can choose one, and just not worry about it too much. Install, a Docker container, or just set up their Bash script, and it will, string together a whole bunch of tools and get you the output you need to do the application analysis part. So I usually classify Recon frameworks in rough tiers. And rough is very subjective and very rough, right? C tier, B tier, A tier, and S tier. And when I talk about C tier, I talk about automation or frameworks that are really just scripting together other tools in Bash or Python. Sometimes they're step-based and they don't really have a workflow to bring back in information to the start of the workflow. There's not a ton of techniques, and there's not a lot of extensibility for the framework. In B tier, I talk about automation, the automation in it, that maybe they're writing some of their own checks or modules, that could possibly put something into B tier. They have maybe a GUI, or an advanced workflow that does bring things back into a queuing system to restart on them. They have a medium amount of techniques, so they're looking for more than just subdomain enumeration. They run point in time usually, so this is a negative, right? They run once and then you have output and that's done. And usually they're tracking everything via flat files or output, like JSON or XML or flat files, right? Then you move on to like A tier, which is you could be writing all your own modules or most of your own modules, or you have a ton of modules. Could also push you up into A tier. Usually has like a GUI. It runs iteratively, which means that it basically will run at one point in time and then run again and show you the diff, and usually manages data via database. There's not a ton in A tier. In fact, the ones I put in A tier in this presentation are like, they don't even actually have all of these. They could probably fit more into B tier. But I thought some were better than B tier, so I kind of pushed up into A tier. Anyway, and then S tier, and these are the tools that most likely you're going to run into that are paid, right? Like these are things that people are trying to build a business off, or something like that. But they have all their own modules rewritten. Usually, they have an extensively pretty GUI. They run iteratively and show you changes. They manage everything via database. They have lots of extensibility. They scale across multiple boxes. Usually they're run as a SaaS service. They'll send alerts to you when things happen, and they have like novel techniques, and they iterate quickly when new technologies come out or when new ways of doing recon come out. And sometimes they're supported by like actual algorithms. I say ML or AI, and usually those are just buzzwords. A lot of time it's just like actual algorithms that are coded pretty well. So I didn't have a ton of time to like go over each of these, right? But what I wanted to do is list out some of the ones I had found to just give you an idea, right? If you want to write your own, you want to see what other people are doing, or if you want to go through every one of these and add the things that you're missing to yours, or just kind of see what other people have done. And each one of these, there's something special. Each one of them, the person has done a couple of lines of adding this tool, or they've parsed in some better way, or they're doing arg parsing when other ones aren't, or just random stuff. And I love to look at other people's code. It's always better than mine, and check it out and see what's going on. So in the C tier list, I have a bunch here. The one that's shown on the right is Ultimate Recon, and I like this one. This one's pretty new, and they're actually using that nuclei scanner as a subcomponent of their kind of tree of recon, right? And just for transparency's sake, this would be the tier that my automation fits into. Would be C tier, right? Mine is all bash based. It is threaded and it does have a workflow, but it's still all on the command line. It's only doing certain things. No GUI, and I'm still utilizing other tools. I'm not writing a lot of my own checks, and that's a personal preference and ability kind of thing. But yeah, absolutely. So mine would fit into C tier as well. Then you have kind of like B tier and A tier. Um, Lazy Recon actually is the first one here, and it shows like their workflow in the upper right hand. I actually say Lazy Recon probably fits in A tier if I had to think about it a little bit more. But there's a whole bunch in here that basically have a whole bunch more checks, and you can check them out. A tier, you're starting to get some GUIs and or just like massive amounts of checks, or maybe even some writing of your own stuff, maybe even some alerting. And when you start to get into A tier frameworks, like you'll notice that some of them are turning into these like managed service type things. So like Find Domain used to be free, and there is still a free version, but there's like a SaaS offering now that includes these functions of like slacking you or telegramming you when a new domain is found, and it keeps iterative scan data over years or months or something like that. And so that one's a SaaS service now that someone's trying to get paid for, which makes total sense. But you're starting to get to that level in A tier. And then you have what I consider S tier, right? So Jcran was on yesterday. I hope he doesn't get mad at me because I took a screenshot of the dashboard. But Intrigue is super powerful. Not only is Jcran writing all of his own modules, he works fast. In fact, anytime I give him an idea, and probably seconds after I finish this presentation, if there's anything that he doesn't have in Intrigue, it's going to be in there really quick. He's just a sharp dude. I'm lucky to know him, and Intrigue is awesome. It has all of the tracking and iterative features, and it's just really good. Um, Asset Note is another one, right? So Asset Note originally was open source, like 5 years ago or 6 years ago or something like that, and then they turned it into a SaaS offering, right? So this is a paid service, but you can see the kind of advancement on the GUI, right? And assets discovered, and they have vulnerability checks that they're doing. And it's just really, really slick, right? And AssetNet's probably a B2B, business to business type SaaS software. So, many bounty hunters are not going to pay to um, that large amount of money to get access to Asset Note. But if you're a company and you want to do asset management, and you want like hardcore recon, you could pay for something like Intrigue or Asset Note, right? The cool thing about Intrigue is that, Jay Cran talked about it, is that the core is open source, and a lot of the code is open source. So, what you pay for is the SaaS hosted version. Asset Note, I don't think is like that anymore. Another one is Spiderfoot. I haven't had a ton of experience with Spiderfoot. In fact, I was given like a review copy to just check it out. I just didn't have time because like everything was crazy with COVID. But I did check. I did kind of like log in for a little while, and the visualization is kind of off the chart. It's got more than just like kind of your normal recon and analysis tools do. So yeah, I like Spiderfoot. It might not be as pointed to bounty as some of the other stuff, and it is a SaaS service that you pay for. And then Project Discovery. So Project Discovery team, we've talked about them a lot. Iceman and everybody else in that team. And this is unreleased, but about 6 or 7 months ago, they released some screenshots of their dashboard that they're making. I imagine it will go a SaaS paid model. But what we're waiting for in this S tier as bug hunters is one that is a SaaS tier because I'm happy to pay for a good product, but is in a price point of a bug bounty hunter, right? Because most of these SaaS B2B programs will, run you a decent amount of money, and they're not trying to sell to individual bounty hunters, right? So, hoping that Project Discovery might be one of the first ones that's really slick that works like this. Otherwise, I would choose Intrigue and use the core open source code and do stuff with that. So, yeah, so this is what it can be, right? When people get to this stage, usually the amount of development required is giant. So they get to this stage and then they kind of go to a paid model. So those are just like some discussions around frameworks. I encourage you to click all these links and check them out. By no means are they exhaustive. I really wanted to say that every person who writes code out there and open sources it is a goddamn hero. So like, it takes a lot of courage to put something out there, and like I just wanted to showcase some of them. I hope I didn't hurt anyone's feelings. I love everything on those lists, and I only put good ones, right? Even stuff that's in C tier, and again, my stuff's in C tier too. So yeah. So that is the last slide for today for Recon. So just some wrap up. So I will put the slides out on the interwebs for you guys to have. The video will be up. Ben will take all of that, and I thank you for your time. Um, so the second part of the bug hunters methodology, which is application analysis, I wanted to have it ready today, but it just is not ready yet. And even though these slides are a mess, I am kind of a perfectionist and I want to make it good. And the other thing I'm trying to do is that in this version 4, I'm going back to the beginning to not just includes updates every time I do the bug hunters methodology, right? Since the beginning, I had very general descriptions, and people have come to me. It's like it's really hard when you have 1, 2, 2.1, 3.1, or 3, 3.1, 4. I have to pull up all of these presentations. So really, I'm trying to include the bug hunters methodology as a holistic presentation, and it'll run pretty long. So the next one is still being drafted. I'm pulling stuff all the way back from the DEF CON talk in 6 years ago now, because people really liked a lot of that content and wanted updated tools and techniques and stuff like that. So I'm working on that right now, and hopefully Ben will have another event pretty soon, and I can drop that, or I'll just drop it myself on the Twitter. You guys can always reach me, jhaddix on Twitter, so twitter.com/jhaddix. And thank you for everyone spending time, and also for all of the people who wrote these amazing tools and came up with these amazing techniques and etc. I'm just I always say it, but the bug bounty community and the pentest community that kind of hangs with us, the iteration in the last 5 years has been amazing in how we're finding vulnerabilities and how we're discovering assets in Recon. So I hope you guys have a wonderful day. I think that's the last thing of the day, and yeah, have a good one. Have a safe weekend. Talk to you later. Bye.